Do I need to grab the screen?
I still don't know what link to give everybody. It does not say. Do you guys? Now everybody in the world will see this forever. Do you guys see a link to give our consumers in IRC?
I don't. I don't suppose it's persistent.
Um, I don't think so. Oh, there's something live actually. I see this here. Let's see. Open image. Um, now everybody in the world will see this. That's me. I think we're close, guys. Close. Oh, now it's like recursively going into everything. I think that would be awesome. I have it here. So the chat guys are saying that they see us, even though I'm too noob to even find it. So I think we can just
Okay.
start. Thanks, everybody. Sorry for the several minutes of wasting your life, but we're going to start our tea time for December 5th. Up next, uh, up next we're going to have Paul talking, so I'll go ahead and hand it over to you, Paul.
Alrighty, here we go. I'm going to pull up my screen. So, if everything's working, you should see my title slide that says "Not caching is hard." Is that visible?
Yes.
All right, great.
Yes, you're good.
So, okay, great. Thanks, guys. So, I wanted to, in the theme I was talking about last time, that I think it's interesting to hear about things that people have developed or fixed or broken or whatever in Medley, and little case studies can be informative in terms of what kind of hurdles people have. Because I think we're developers, we're optimists. We think, okay, well, here's the definition of the feature, and I'll implement it, and we will test it, and then we'll deploy it, and then we'll do the next feature. But in reality, lots of fun surprises happen along the way. So this is relating to a ticket that came from a while back. The the requirement, in short, was let's use our analytics to track each image flip in galleries. These are not page loads. It's an AJAX load of each image. And metrics, understandably, wanted data on what people were doing in there, not just did they load the gallery page or not, but did they flip images and so forth, because we're selling ads as interstitials in there, and so we need data to do that. So let's do that, sure. The vendor being used, the analytics vendor being used to track this is Comscore. And one of the aspects of the ticket that is one of these things, like I said, where we don't really know until we get in, what is it? How does it work? It is not just tracking server-side stuff. In fact, they have patents into things, and in short, you don't have to digest this diagram at all. It's really gratuitous, but it's actually relevant. Comscore operates by running a local proxy on their user's machine. So they have a panel, sort of like Nielsen, of users who are browsing the web, and those users are all running this local proxy, which reports stuff up to the Comscore mothership. And so they just do their thing, the users, and the data as to what's coming over the wire to the user's machine goes up to Comscore. So that's what we got to work with, is that we have to do what that system expects in terms of requests and responses, so that it can properly report the traffic we want to report, which is image views inside galleries. So we get the gist from ComScore, and their requirements seem pretty simple. We're going to add an AJAX request with each image flip. That request needs to be answered from the server by a response that just has the string pageview_candidate in its body, and it should be a 200 status code. That is it. That's the entire requirement from ComScore's end as we first understood it. Sounds super easy. This is a request that's just going to be a throwaway. It just has to be made so that that magic string passes through the ComScore proxy so that then they see it and they record the hit. Easy. Oh, but we can't use just one file for all the properties. Our first approach was, let's make a JavaScript file that has this in it, and it's a static file, and it'll be on our media servers, and it'll scale just fine and super simple. Static file, deploy, kaboom. Well, ComScore informed us that they could not track that because the URL was not mapped to the property, so that if AJC is getting media from our media server, it's a shared media server across all the properties, and ComScore, their little proxy, didn't have the smarts to suss out that that was a request specifically to AJC, which foils the whole point of it, which is getting metrics that track to sites. So, okay, can't use a static file. I should have included a grab of that, but this was version 2, which is, let's just make the simplest possible medley view. All it does is returns that string in an HTTP response, and it's just plain text, which is acceptable to them. That's all it does. So, a little bit more hassle than the static file solution, but super simple, right? No problems, right? Except, what if you had an event in your media ecosystem that caused a surge of, let's say 10 million additional page views in one morning, and you have just added a medley view to each, a medley view fetch to each image view that happens in those image galleries when Drudge and whoever else are sending people your way to marvel at Atlanta in snow, just to pick an example of something that was mentioned in a meeting about this ticket, which might have involved people threatening to leave if such a thing were implemented. So, can't just have a bare view, it's got to be cached. But we can't cache it in such a way that ComScore proxy doesn't see every hit. So, this is where Akamai came in, and this Jason Antman suggested this, getting Akamai involved. We added a special rule to the Akamai config for all the servers, started with 1FE and confirmed that it worked and rolled it out to everything, that says for this one URL, this ComScore page view candidate endpoint, don't tell the client never to cache it. So what this means is that Medley doesn't have to serve every one of these requests. It serves it to Akamai, and then Akamai serves every single one. Akamai tells the client never to cache, and the whole point of that dance is so that the client from the user who's a ComScore panel member, request goes from their browser to Akamai, and Akamai sends back the response every time. The user's browser never thinks it has it already, because if it did, it would not make the request, and it wouldn't register the hit on the image flip, and we wouldn't get accurate numbers. So this Akamai config pretty much saved us, because Medley can't serve that much traffic. We saw that painfully in the end of January last year, but we needed to not have it cached, and so there we were. Akamai config set it up, so now we're done. Oh, but wait. Keith Batesell, bless him, noticed while watching the logs that there were a lot of what looked to be cache busters getting appended to these requests. This request that we had very carefully tried to not get Medley to serve every time because Medley can't handle it. And here's these cache busters, which are essentially forcing Akamai out of the way and forcing the request to go to Fat Medley, which is the most resource-intensive way we could serve this tiny little string. And it wasn't a critical issue in production with normal traffic levels, but it was noticeable to a degree. And we knew that with the traffic surge, it could crush us. So, hey, cache busters, that's weird. Turns out that jQuery's AJAX method by default appends cache busters to every request. Did not know that. And so here's the end, and this explains the cryptic title of my talk. That in the AJAX call that we're making inside that update ComScore method, we're saying cache true, meaning allow caching on this, meaning don't append cache busters, darn it, jQuery, so that we can get every hit to these images registered. And that is the end. Welcome any questions if there are any. You can watch IRC. Or John, you can pass the mic.
All right, cool. Do we have any questions? Trying to wait the like 30-ish seconds or so for buffering.
I'm good.
Cool. Where is the screen share? Uh-huh. All right, you guys see my MMO?
Looks good.
All righty. So MMO, the dirty deeds of game and MMO hacking for lulz and profit, part 1? Question mark. I really doubt that I can cover everything. It's just so much, and I'm not even done with my slides, so deal with it. Shooting for 10 minutes, so yell at me if I go too long. So firstly, just some context. Why me? What have I done? That kind of stuff. The stuff that you can kind of tune out for the next 2 minutes until I get to the good stuff. I've written a bunch of bots, mostly for games, some web stuff, including Diablo 3, World of Warcraft are kind of the cooler ones, which use memory injection, image recognition, and various forms of AI. But qualifications, why not me? I'm actually uber noob. None of that stuff I'd say I'm super awesome at. I feel like there's just always so much to learn in all those domains, and I know just enough not to get me caught 80% of the time. I have a sad story that will come later, and I've not nearly mastered any of the stuff that I just talked about, and I do know just enough ASM for in-scene hooks and some injection, but man, it can be scary stuff sometimes, and I'm probably the slowest dude at it you've ever met that did anything. For the qualifications, I haven't done this in quite a while. I'm reformed. I dropped it, man, like a bad habit. I shamelessly ripped some of the pics, mostly because I didn't have any. Not much of a memory dude, but I needed some sort of content, so a lot of it's just made up. So if you call me out like, you never had a Tauren elf or whatever, like, yeah, I didn't. I just took that stuff just to fit my talk. You got me. And any player names, all that stuff's going to be made up just from the content. So, beginning. Why would you want to pwn your game? Grinding is pretty lame, depending. I mean, maybe you're awesome in Korean and just love that stuff. I actually like it quite a bit myself, but it gets tiresome. Generating cash, super lame. World of Warcraft, oh man, I do not want to run around all the nodes and just sit down and pick up stuff for hours and hours and grind up my levels. It's terrible. And I want to pay for the subscription for the game, but not actually play the game until I'm elite. You hear that. It's a thing. I do that. It sounds pretty dumb that you're paying for something and you don't actually play it and you get a bot, but hey, it's cool. We do computer stuff. How can we own the computer? How can we understand it further? I don't know if you guys recognize this guy. It's pretty awesome. You should. It's a Kingdom of Loathing guy. One of my first bots was Kingdom of Loathing Omancer, Colomancer. There's a class in the game called Postomancer, of which I was a part. I wrote a bot, links right there. It uses very simple AutoIt script. Quote from one of the AutoIt UDF developers: think of IE as an API. Not a big Microsoft fan or IE, but when I read this, I thought that was helpful, maybe insightful, maybe not. Either way, I figured, well, I'll see what this guy has to say, maybe use some of his stuff. So, what AutoIt is, what it does is it automates Windows, both input, primarily for input, but all around uses the API and invokes different Windows API calls to do your bidding, automation type stuff. But there have been libraries that have come up around it to support other things, like, for instance, Internet Explorer. Com Control is surprisingly, in Windows world, I don't know, you guys probably all hate Windows like me, good job, but Com is an interesting element that we can manipulate, control, we can query a lot of things. There's a lot of Windows support for it. So, IE, with its reliance on Com, lets us control it to great detail, so we can figure out everything about the browser, its current state, how to invoke different, button presses, all that stuff. Libraries also exist in AutoIt for image recognition, and my bot was so much faster than I was at actually clicking the buttons. And you may say, okay, noob, idiot, why did you actually start an Internet Explorer when you could just get Python, beautiful soup? Blah, blah, blah. Yeah, okay, you got me again, good job. There is an awesome bot out there called Meat Machine. You guys should go check it out. +1 on that, but there's plenty of that that's been done. AutoIt is pretty interesting in that it's pretty future-proof. Like, if they change the API, like, you don't need an API key for one. 2, you don't need an API at all. You just press the actual buttons. And 3, you can use those skills for anything, which I guess is similar to RESTful services, API, etc. But it extends, I've found at least, it extends to other domains that are very helpful. Here's a little snippet of what it would do if you were to get away from AutoIt. The simple Windows API call called sendInput, you can, now I forget which one this one encompasses, but there are functions to easily move the mouse, click a button, whatever, and that is what AutoIt handles really easily. The middle link that says from topic 13 blah 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 Internet Explorer, that is the UDF to control, go to links, go forward, go back, all that stuff in Internet Explorer. And I've added an open source image recognition library at the very bottom, which I've used in other AutoIt things. Very helpful. It can fuzzy match images, and by that I mean it can get the pixel colors, so RGB, and say, oh, it's within like 5% of this other image that you've given me, or it's within 10% or whatever. And you can go very far in that. For instance, I made a League of Legends bot that plays custom games. Oh, this is a long time ago. It just plays custom games, and you can only play Civ, and you can only play, all this certain constraints. But it used to get you first win of the day. It used to get you IP. It used to play the game for you, so you don't have to be subject to playing your fun game. But it does cool stuff too. Pixel search is included, so you can search by color. And then, of course, using the image recognition library to approximate game state. So I could say, that looks like a destroyed turret, or that looks like an alive turret, so I can progress to my next stage, the next state in my state machine, if you're so inclined to do it that way. Or, sure, there's a minion right now and you're about to get headshot, so back up, or something like that. And probably my favorite all-time is the Diablo 3 farm bot. It was my most lucrative in terms of like US dollars. I got 10 million gold per hour from a guy called Sarkoth, and 2 to 3 of the highest gem a day, which eventually came out to be about $35 US dollars per bot per day. It didn't last very long, but for the time that I did it, it was pretty fun. There's an OCR UDF as well for AutoIt, so that you could, if you kill a mob, you kill a monster in game, and they drop some sort of really awesome item, and you have the text that says, oh, this is plate mail, this is that, this is this, and it's a certain color, so you know it's legendary or unique or set or whatever, then you can match and you can find out what kind of item that is with OCR. You read the actual screen, figure out the characters, look at another library that you've built up or some sort of online resource to figure out if that item is worth it, pick it up. Pixel Search can figure out those rarities with the colors and where they are. And you can do stuff like figure out where enemies are with changing some of the game settings. You can turn on the health bar in certain ways that you can really easily match. Though, at the end of the day, I got the band hammer. I hit rock bottom. Bad news, I was very sad for a while. My characters that I loved and were near and dear to my heart, that I was quote-unquote playing the game even though I wasn't really playing. That was very sad. But, like I said, I'm reformed now. This is an example of Sarkoth. You do like a couple jumps, you do some teleports. Here it is, you get like 40,000 gold. It was quite a lot after all the gold find gear, that kind of thing. Let's see, kind of looking at time while I'm reading boringly before we get to the good stuff. 425. So beginnings in 06, there were $200 to $900 million of US dollars in revenue from just all botting. This is probably the peak of botting since World of Warcraft went. I don't want to say they died, but it just wasn't as popular since then. And you, as a game character, of course, would want fat stacks of cash to line your in-game armor and blocks of gold so that you can use them as blunt force instruments on bosses, that kind of stuff. You want to just be filthy rich and not even care sometimes. You want to make it rain gold. You know what I'm talking about. So, that was helpful. The first figure of getting money was helpful. And of course, everybody wants to go to CD websites and meet up with a level 1 trial account character using generated names in neutral towns. And it would seriously be like, I remember some Jay-Z song where he'd be like, yeah, cracking my palm under the lamppost. It's super late at night and I meet with some crazy dude. It kind of felt like that a little bit. I know that's super dumb because I'm on a game, but it's like, yeah, let's meet in this alley and Ratchet in this neutral town at this time and meet this character and you say these special words and yeah, the weather's great outside, and it was dumb. but there was something alluring to it still. So, getting to the medium interesting level stuff, aside from the boring crap I was just talking about, let's break it down and get into more interesting memory manipulation and game logic. Now, man, I'm going a lot slower than I was expecting. I'll wrap it up soon, but get to some interesting stuff first. First, in games, generally you have just a game loop which renders and updates. You have some sort of manager that handles variables and lists of objects and other boring crap we don't care about. Portable executable. Oh no, I got a ding. I assumed that I should shut up or something. Oh no, that wasn't about you guys. Never mind. So portable executable has special thing on this, I guess, is the headers. Tell the linker where to map file to memory. So for every chunk of code, it will be somewhere in memory. And this key feature, Sub-Zero, the IAT fills out library memory addresses for dependent libraries. And in conjunction with key feature 1, where all addresses are fixed ahead of time, you can guarantee that various code will be mapped to certain spots in memory. So I won't read that qualifier because, again, I kind of took it out of context. But the takeaway is that memory is fixed in games and that we can access it. So how can we leverage our knowledge of games and portable executables for great justice? Firstly, variables are statically given addresses. And it can be tricky because, like, for instance, AAA games like World of Warcraft have masked these variables by a series of pointers, often going up to like 7 levels, and it can be kind of tricky to go up there. But once you've done one, it's pretty easy to go up through several levels. Secondly, so we can figure out where these things are. I mean, I don't know if it's intentional, but just think about every game that I've looked at, there's some sort of manager, and it's kind of at the beginning, and they all have dynamic contiguous lists. I don't know why they keep doing that, but that's how it is for what I've seen. Per PE, so every new version it's different, that kind of stuff. So we can find base addresses for the PE, for variables, lists, blah, blah, blah. Variables could be stuff like gold, player health, location, that kind of thing. So we can start small. You need to first get permissions to be able to read memory from a process. You need to attach the debugger. Very similar, honestly, to PDB. I know we all love that, but it's pretty much the same thing. Reprocess memory. MSDN, I mean, it's all documented. They're down with that. Yo. But you'd say reprocess memory. We gotta scan hundreds and hundreds of megabytes for stuff that we don't know about. Unknown and changing values. Gross. Well, there are tools out there for these kinds of things. Cheat Engine. Since I showed you that one code snippet, now I'm totally allowed to freeload off others' work. So we can use this to scan, get the information that we want, debug running code, blah, blah, blah. Let's see. Well, I name dropped Cheat Engine, and we're at 4:30 now. I'm kind of inclined to just call it a day, even though we didn't get to any super awesome stuff. What do we think? We want to continue, or should I? Another 5 minutes or another 10 minutes? I'm at that lame stage where I'm presenting and I don't know what we want. What do you think, guys? PBX?
Mine is only like 5 minutes long, so personally, I don't care if you keep going.
Okay. Oh man, see, I'm clicking all the wrong buttons because I'm being recorded, of course. Well, I'll continue a bit longer. Where is? Did I close it all the way? There we go. All right, I'll go a little longer. I'll go till 4:40 maybe. So, Cheat Engine. Cheat Engine allows you to attach to a process. You can scan its memory. You can record that process's memory locations, depending on what you find. You can debug running code. You can change values live. Whoa, exclamation mark, that's awesome. And you can no-op certain operations intelligently. I just heard a ding. I'm not going to look at it, sorry. I'll look for questions. Hopefully you're saying, yeah, continue. So let's look at an example. Let's play, quote-unquote, Plants vs. Zombies. And by play, I actually mean let's hack that game that we bought. So Sun, background information, Plants vs. Zombies, Sun is like your resource, your currency. It's your gold, it's your cash, it's what you use to buy stuff. So, process. Oh man, I'm playing this game, and I'm so bad, I'm poor and noob, my eco isn't up, my APM sucks. The zombie with the hat is coming to pwn me. Zombie with hat has like more armor, quote unquote, I don't really know what they call it. Anyways, we can use Cheat Engine, we can attach to PopGot Game 1, and we can say, well, what is Sun? Okay, like what's the value? What's the data type corresponding to Sun? Because it could be a float, it could be an integer. We see in game it goes up in increments of 5, and it doesn't have any decimals, so we can infer it's probably not a float or a double, but who knows? Let's just see what happens. And then at the end of the day, man, that zombie with the hat, it's just so stressful. It's tough. Life is tough in the first world playing your game that you don't want to actually play correctly. So we start with the actual value, which is what you have right now. What of your resource do you have? I want to say at this point I had like 25, 35, something like that. You want to do an initial scan. I have an example. I have a screenshot in a second. So, well, here, maybe I'll just show you. So, remember this, commit to memory. All right, going back. So you can use filters to first scan for a particular value for a particular data type. I don't think you can see my mouse, but there in the middle there's a value type. It's currently all. You can scan for 4-byte, you can scan for float, you can scan for whatever. But right now we have all and no unknown initial value. You can say I want it to be exact, I want it to be 35, whatever. Anyways, you have a bunch of filters. And sometimes they don't work. I say mention it, but I don't know that I really have time. Maybe I can mention it next time. I don't know. Apparently I'm talking really fast, so I probably do have time. Sometimes you can be exact, but sometimes you can't. Plant vs. Zombies, why I chose this one for when I was preparing last night was the old version, while it did go up and was monotonically increasing, in memory it would be multiplied by 5, so I'm saying it kind of backwards. So when you have 25 Sun, it would go up to 30. In memory, it was actually 5, and it would go up to 6. And I thought that was tricky enough, and it'd be cool to show you guys, but then I was doing it late last night, and it is actually 25 and 30. And maybe I'm just remembering like the wrong game did that. But different versions of the games could behave totally differently. You can stick it in a much smaller value, in a much smaller data type, if you multiply everything by 5. But yeah, I find out later, you'll see it's not actually that way. But you got to be aware of that kind of stuff. Sometimes your resource isn't the data type that you expect. Sometimes you can't search exact. Sometimes you got to start with unknown value. So start with value type all, because who knows. IEEE 754 float, who knows what that looks like versus 4-byte int. Well, we know because of the Mantissa and its document and all that stuff. But whatever, it's different. Again, here's the game. Notice at the top, it's attached to PopCap Game 1, and you have a memory address on the left. This is like mildly borderline interesting. That screenshot's kind of boring. The next one is better. So we scan. So this is our initial scan, and then we execute the scan, and now this is like between clicking the button and the results. So your initial scan returned like 1 billion things, you idiot. Yeah, well, that's because we're scanning all the memory for any data type of unknown value. So yeah, imagine how many bits could possibly match that criteria. So you scan several times, you change it, you iterate your filter, you get down to the correct value. If you collect more sun in-game, then you can go back and you can say, well, now that value, wherever it is in memory, now it's bigger. So filter out all the stuff that doesn't fit that criteria. Then we get something like this. This is finally the getting not trivially boring stuff. We see on the left side, I finally scanned over time the red value 125 and the bottom 2 memory addresses, 1CC25620. 125 maps to the sun in Plants vs. Zombies. In the top left of the Plants vs. Zombies window, you'll see 125. That's the same. That's what it is. It was 275 the last time I scanned, by the way, and I must have bought, like, I see that the big potato dude with eyes, apparently I bought him recently, and then I bought something else because that doesn't quite add up, something for like 25. Or maybe I bought something for 50 and farmed another 25. Anyways, I found the memory location, 1CC25620. It's awesome. That's kind of cool. I like that. Oh, cool. Yeah, we have it. But it could be 2 or 4 bytes. So also notice back here on the Cheat Engine page that the :2, :4, that represents 2 or 4 byte if we're back in the value type. That's kind of like the data type. And it's unclear if it's going to be a 16 or 32-bit integer. So I say, man, it's Plants vs. Zombies. We're offline. Let's just run amok. Let's try some stuff. Let's modify that crap, right? So in kind of, I mean, I've done this a few times, so I kind of decided it was 4 byte because, I mean, it's Plants vs. Zombies. Who's going to care if you use an extra 16 bits of memory? Man, but you know, I want to figure it out, and I was giving the talk, so I guess I gotta fill in all the dumb little jots and tittles. So, is it 4 bytes? What's the easiest, lamest test value? 99999. Why? Because you can just stick your hand over it, and you're gonna be typing in a lot of numbers when you're twiddling bits in your memory editor, and 999 is the go-to. That is what you do. So, this is a convenient value because even if it's unsigned, int 16, it's 65,536, and 99999 is bigger than it, and you don't have to move your hand from 1 to 0. You'd be surprised, man. I see people go 10000 0 so many times. Just do 9s. It's better for everybody. You'll be so much cooler. I will totally give you props. Though, interestingly, and I don't show this in the screenshots, but while the game is paused, yes, it gets to 99999, but the game itself caps it at 9990. It's Plants vs. Zombies. Who cares? So you'll see now I've edited that memory, and I don't know. Let's see. I don't think I actually talked about how you do that, but you go to the bottom of the screen and you double-click on the value column. It'll bring up a little thing that you can change some of the values. 2 minutes left. You'll see that in the top left for Sun, for Plants vs. Zombies, you'll see 99999. Now, you remember that game loop, you got to render, you got to update. When it ticks, it will go back down to 9990. That's what I mean. So, yes, right here, it looks like it's a 4 byte. I say it's a 4 byte because now it's reflected in the game. That when you're changing memory and you see that the game reflects a 4-byte change that you did, then that guarantees you got a 4-byte value. So over here, just assume you interpret it as 4-byte, because otherwise those other 2 bytes are just 0 with the 2, and you kind of don't expect it. So that's what I was kind of thinking for. But this confirms it. The UI expects it. That means it's reading 4 bytes from those blocks. So you're good to go. Let's see. That's pretty good. I'm deciding. I think that's good for today. I know that this talk would be broken up into a couple of different sections, so I think now would probably be a good place to ask for questions. So, do we have any questions? I went ahead and dropped it down here. Miracles, you know it. I'll wait the requisite 30 seconds, 20 seconds. And we got so much more stuff. See, I'm only on slide 29 because I'm so slow, and I have 42 slides and I'm not even done yet. How I got into software development. That is not how I got into software development, Paul. Game stuff. I wanted to make games, really. I was in late high school and early college, especially freshman and sophomore year. I really like games. I started out with like text-based, went on to the Windows GDI, went on to dumb DirectX. I say dumb because it's Microsoft and it's closed sourced, broken, and a few other things. Anyways, I like games so much. I like playing games a lot. I've always liked playing games. I've always tweaked around with them. I never really like hacked them, modded them, all that kind of stuff. That was more in college. There's a time and place for everything, and that place is college. But no, this didn't really influence my desire for computer science. I've definitely brought it out, like doing the master's stuff. I dropped some of that hackery bomb to the professors, and they would hush me, but, you know, whatever. It's really helpful stuff. I mean, especially in architecture, it's very helpful. So, no, I can't say that it led me to do development, but it helps a lot. Well, the next one I see is Sad Story, and Drew believes is like one line too long for me to actually read. The sad story was Diablo 3. I got banned. I had a lot of really high level characters, which, I mean, I forget actually what it is, like 60 at the time, originally when Diablo 3 came out. I had like 3 or 4 max level dudes, and when I was running the bot all day, every day, running this one monster that's like a really dumb super unique, and he only drops money, and I ran him 24 hours a day, and all of my characters sent him money. Yeah, they caught on to that, and they banned me. So that was very sad, and I lost all my work. I actually wrote them a really long email that was like kind of joking myself, and it was like I was kind of a drug addict, and I was like recovering, and I hit rock bottom. Pretty sure I was like, man, I experienced the higher power. I yielded to the higher power, and I'm a reformed man now. But they didn't care. They were like, yeah, you're banned. You're dumb. So I bought a new account. That was the sad story. Oh, man, these questions. It's like 3 lines longer than I would expect. You talk about x times 5 to store a variable. Yeah, so if you want to counter... Ian, I think it is, Ian Burnett. If you want to counter a botter, yeah, it would definitely help to mask your values in memory somehow. Now, you'll have to beware because at the end of the day, somewhere your UI is probably going to show that number, and you can, if a botter's getting frustrated that he can't figure out that value, he can probably just OCR it from the screen, if that's possible. If you have some back-end values, I was kind of thinking about that because I was kind of anticipating a question like this, and it's tough to guard against that, 1. 2, it would be expensive depending on how you'd manage. 1, you're going to have to like totally change how memory management is done for your game. So you'd have to like encrypt your crap. And even after you do said encryption, if the guy, you'll only be delaying the time. So a modder will probably find the key because it's got to be in game memory somewhere. You're probably not generating it, though. That would be cool. Okay, we started up time 0 milliseconds since 1970. Use that as the encryption key for pretty much everything. I could see that being helpful. It will be misdirection. It will be tougher for a botter. He can still do it eventually, but maybe that would discourage a typical botter and help you. I mean, even just the dividing by 5. That threw me off. When I first did whatever game it was that did the multiply by 5, I searched exactly for what resource I had. I didn't find it. I was like, oh no, I give up on life, uninstall, uninstall. No, I mean, I did have to do another search, but maybe somebody would reverse that. Yeah, I mean, I'm seeing some VAC too. So there's a lot of, when you get into PE modification, which is what I want to do eventually, by the way, so like towards the end of the talk. I added a link to this PowerPoint, by the way, so over time I want to extend it. I'll actually jump to the end because there's some kind of mildly borderline interesting stuff. Eventually what I want to get to is World of Warcraft. They have a Lua engine. I want to invoke that. Man, I'm really killing some time here. I'll relinquish it after I finish this. You want to invoke functions on WoW's Lua engine. That's pretty cool. You can roll your own tools, like I always talk about AutoIt or Cheat Engine or whatever, but eventually you're probably going to want to roll your own tools. It's just faster eventually. I think they're great tools, man. I don't want to downplay them, but eventually you'll probably get a little past that. Do some AI. Maybe it won't apply here, but it'd be helpful. Then the hot stuff, which is kind of VAC, is verifying integrity of the game. Warden. How do you combat Warden? How do we get some ASM in there? How do we do in-scene hooks? How do we carve away our own section of the WoW running client, claim it as our own, run our own arbitrary code? That is awesome, and I want to get to that, but that's not for now. And I'm way over. I think it's time for me to relinquish, but thanks for your questions, guys. I don't know where the window is, but Kevin, are you ready to take over?
Yeah, I'm ready. So, okay, just let me know when my screen is shared and all that.
I see ES6 promises.
What's that? Am I good to go?
Yes.
Okay, cool. All right, so this is just a short sort of status update on where we are at with ES6 promises and whether they are ready for us to start using in our JS code. Okay, so I'm not going to go over really what promises are, how to use them in this talk. There's some links. As usual, the Mozilla MDN documentation is really good. So I suggest, if you're interested in the topic, I suggest going there first. And there's links off from that page. But basically, they provide a way for us to compose our callbacks. So we can combine them, we can link them, we can chain them. It provides us a way to organize our asynchronous code into something that's not a complete mess, basically. They are being introduced into new HTML specifications. So right here I've got the fetch specification, which is kind of like the new and improved replacement for XML HTTP requests. So here's a link to the specification. Okay, so this is IDL, which is kind of a pain to read, but basically this is saying that that the window object is going to have this function called fetch on it, and then so you just say, you don't have to say window dot because it's global, so you could just say fetch, and then put in your request info, however you put that in, and it's going to give you a promise for a response object, and then you can use the entire promise infrastructure to combine, chain, etc. Okay, so current browser support. Promises are actually now shipping in the current versions of everything except IE, which is kind of not surprising. But if you go to the Can I Use website, you can see the current status of support. And they're working on it for IE, which is good, but we have to consider that case, and it's not supported in Opera Mini, whatever that is. I don't even know, but you can see it's been in Chrome for a while. It's been in Firefox for a while, and Safari has good support as well. So for IE and Opera Mini, I guess, we have polyfill. So it's entirely possible to implement ES6 promises with library code that runs in ES5 or ES3. And in fact, since November, we have one of these present in Medley's Core.js pipeline for across all of our site types. The one we're using is actually an adaptation of V8's promise implementation. V8 implements a lot of its standard library stuff in plain JavaScript with some special V8 internal stuff. But so this particular polyfill is basically just a port of that implementation. Yeah, so that's pretty much the end of it. You can go ahead and start using it in your Medley code if you want to. I've got some code that's actually running in production that uses promises. And if you have any questions, feel free to hit me up on IRC, and I'll be happy to answer them. That's it. Sorry for the sounds of the home.
Yeah, you're good, man. So, Kevin, where's the promise code in Medley?
It's under media. It's in a Bower library called V8 Promise.
Cool, man. Thanks. Thank you so much, Kevin, for your time. It sounds like you have other great duties that you're attending to. So next, I think we have Chris. Are you good to go?
This is Caleb.
Caleb?
There's two of us C. Smiths. I know it's confusing.
Okay, cool. Yeah, my bad.
Yeah, no, no worries. All right. Can you see my screen, everyone?
Yes.
Okay, cool. So today I'm going to be talking a little bit about Scheme, and in particular I'm going to be talking about a project I've made called Automaton. This is kind of a silly, fun, experimental sort of project. I mean, it's pretty stable and it works, but it's just kind of made for fun. So it's written in C, and it's a cellular automata runner. So think of Game of Life and that sort of thing, but it runs some other automata. And so here you can see a GIF of one instance of it running. So you have Game of Life, and it's in running in a terminal with like a text interface, and then I also have like an OpenGL graphical one. And this second one, well, it's not a GIF, so you can't see it animate. We can look at it in a moment, but this automata is called Brian's Brain. So anyways, it's a little bit of a bear to install on anything but Ubuntu, but for Ubuntu I do have releases in the release section, and you can download it and run it pretty easily. Otherwise you have to have some fun building C code. Anyways, today I'm actually mostly going to talk about its Scheme API and how you can program it in Scheme. So what I did is I used Guile Scheme, which is a scheme implemented by the GNU project. And it's used in a small handful of programs, hopefully a growing number of programs. It is the official implementation for the GNU system, but it's not used a lot. Anyways, so I essentially have various procedures defined that will get and set various properties of the board from scheme code so that you can implement an automata in Scheme. So briefly, we'll look at how we might implement or what this looks like. So first, we'll go ahead and watch it run. So this is running the Game of Life using Scheme code, and it's running in the text interface because you can see it's running in my terminal. So that, if we look, is this code right here. So this is the Game of Life as it's implemented in Scheme using the those procedures I've defined to kind of hook into my code. Just briefly, just to kind of get an idea of the program, we'll watch it. So this is Brian's brain running in graphical mode. This one doesn't actually use Scheme, so there is essentially some C code that runs, loads config files and parses them, and then can get their set of rules that way, and it works for a variety of automata that way. But anyway, this one's cool, but I'll close it so we can move on. So Scheme is essentially a Lisp, and I think that a lot of my audience is fairly familiar with that family of languages, and I think I realize some of you are not so much, and that's fine. So just real quickly, I was going to kind of talk about kind of an introduction to its syntax and whatnot. So essentially, Lisps have this idea of expressions, which are called S expressions, and they all begin and end with parentheses. And so an expression typically starts with a function and then has some arguments. So essentially, this Scheme code means call the function func with the arguments arg and to. So another way to say it is do this, being the first thing, with these being the rest of the arguments. So as a simple example, I've got a REPL here. You can see I ran plus 1 and 2, and the answer is 3, and then I nested them with times, and I've got some invocations of plus with 1, 2, and 3, and 2, 3, and 4, and so forth. So it does nest the way you would expect in terms of math. And so you can essentially look at the deepest nesting first, evaluate that first, and substitute it with its answer. So essentially, in the above, I would look at plus 1, 2, 3, and mentally do that substitution of 6, and the next one of 9, and so you multiply 6 and 9 and get the result. So that's kind of the gist of the syntax and how it works. So, in particular, with my program, I've got board set cells. So you've got an x and a y, which you apply, an x and a y value, and then some number for the state. And for the Game of Life, there's just 2 states, alive and dead. So there's 1 and 0. And then here I'm calling rule func to determine what it should be, and rule func is passed in as an argument. So one thing about Scheme is that it is it's a Lisp 1, as they call it, but basically functions can take functions as arguments, and they're not in any sort of special namespace. So here, rule func, neighbor, and neighbor func are functions. And then, so essentially, most of this code is sort of boilerplate around the function here at the top that defines the actual set of rules. And so if you're familiar with Game of Life, this will look familiar. So essentially we have a current value of the state of the cell in one place on the board, and we go through each cell in turn. And for any given cell, we also have the sum total of all of its neighbors, which are living. And so if the current cell is dead and there are 3 neighbors, then a new cell will be born. So essentially in the next generation, this cell will become living. Otherwise, it'll be dead. and if there are 2 or 3 neighbors, then it will essentially survive if it's already living, or otherwise it will die. So one thing to point out: the if procedure, essentially after this predicate, it takes 2 expressions, and the second one is for the false case. So in this case, so if current is 0, this one will run. Otherwise, this one will run. So that's kind of how you read those. So yeah, and so essentially the generate next calls maps and goes over the widths of the and height of the boards to kind of generate a full board. Yeah, so when we watch it run, we have this. So we see the Game of Life using that rule set we were just looking at. Because it is a Turing complete language sort of thing, and we're not necessarily bound to implementing a cellular automata in a sort of pure way. So we can actually kind of implement some of the stranger ones. So there's one called Langton's Ant that I have an implementation of here, and in this one there's essentially one little weird bit of state which we call an ant, because it appears to sort of walk around like an ant, and essentially it faces a certain direction, and we make it turn, and as it walks, it flips the state of cells from alive to dead. And if we look at that one running, we'll see this, and I'm going to zoom in a little so we can kind of see it. So you can see it looks kind of like a little, if you use your imagination to squint a little bit, it looks like a little ant kind of running around digging tunnels and stuff. I wish I had a little more time and I would dig in a little more, but at this point I think I'll just take questions because I'm out of time.
Looks pretty cool, Caleb. I'm asking for questions in IRC.
Thanks. Yeah, I'm watching, and I don't see any. So yeah, and if people are curious, so it is on my GitHub as Automaton, so it's Caleb Smith Automaton. The scheme code is in SCM. The C code is in Source. It is kind of a toy project. Like I said, it mostly works. It's not exactly beta quality or anything, but it is kind of just a fun thing. If you're real serious about cellular automata, there's several implementations that are really good. There's one called Golly, for example. But this was kind of a project I used to kind of figure out how to embed scheme code and kind of toy around with it within a C project. So. Okay, cool. I don't see any questions, so I'll stop screen sharing.
Cool. Yeah, thanks so much for your time, Caleb.
Thanks.
And thanks other presenters. I guess Kevin pieced out, but thanks Paul as well for your time, and thanks for the viewers. It's viewers like you, and we'll see you again. I think it's just 2 weeks away, so keep brewing your tea. We'll look for you then. Have a good night, everybody. Bye.
Bye, folks.